So just give me a moment while I share the screen. Hold on. All right, should be seeing a PowerPoint. It's a little slow on my end. The internet's not been super cooperative all day for me. So again, I'm Dr. Kristy Mulkey, and I'm the workshop coordinator for 240 Tutoring, and I'm here in our Praxis study group on Facebook to do a little math with you today. So we are going to be looking at topic 3 of the math subtest for elementary, so test 5003. We have done this the past couple of weeks, so if you want to check out topics 1 and 2, you can find those videos right here in our Facebook group, or if you're watching this on YouTube, you can find it in our Praxis study group channel. So you can check out topics 1 and 2 by just looking for those videos from the last couple of weeks. Now, our purpose here today is to give you some specific help with your test, with your competencies, your standards, and I'm going to work through some questions with you to try to give you some strategy, teach you some skills, and provide some explanation. So we are looking at topic 3, which is geometry, measurements, data, statistics, and probability. So if you look at this, we are looking at understanding 1, 2, and 3-dimensional figures. Forgive me, my pen and mouse and everything are lagging just a little bit. The internet where I'm at has just decided today it's not going to be super cooperative. And okay, so I'm not going to use the pen. I'm going to attempt to use the mouse, and it's going to be difficult. Okay, the joys of live technology, right? Oh, fun. Let's try this one more time. All right, forgive me, guys. I'm going to try to exit out of this. Just stick with me. You're going to see my screen for a minute. I'm just going to check my internet connection. I'm going to do what teachers do and improvise and hotspot off of my phone and see if I can't eliminate that lag for us. So bear with me for just a second. I'm so sorry. Okay, we're going to try to connect here. Hopefully I didn't lose you. Looks to still be working. Okay, so I'm going to try this again. Thank you so much for your patience. Learning the joys of teaching here. And I know a lot of you are looking at becoming teachers and teaching online. This is part of the fun part. Okay, so we're going to try this again. Let's see if my pen will pick up now. Oh, there's still some lag there. I don't think it's going to work. Okay, there we go. I'm using the mouse. So it's going to be fun to watch me write with this mouse today. So stick with me. So we're back to looking at these standards, and you've got to understand how to classify 1, 2, and 3-dimensional figures. Part B, know how to solve problems involving perimeter, area, surface area, and volume. C, know the components of coordinate planes and how to graph ordered pairs. D, knows how to solve problems involving measurement. E, familiar with basic statistical concepts. And F, knows how to represent and interpret data presented in various forms, so looking at charts and graphs. And then G is familiar with how to interpret the probability of events. So we're going to do some practice problems together, and we're going to hope my pen works and I can actually write and show you how to do this math. So we're going to move on to the next slide. So let's do some problems together. These are all coming from, if you look at this down here at the bottom, the Praxis Study Companion, which can be found on the ETS site. So these are the free and public questions that are published out there for you to use. They do provide explanations for these in that study companion, but those explanations, especially in math, are often written for people who are mathematicians. And sometimes reading those explanations, even for me with an extensive math background, can be overwhelming and challenging to understand. So I'm going to try to provide you some explanations today that are a little more simplistic and easy to follow. So our first question, number 4 here, has to do with probability. It says a student plans to simultaneously toss a fair number cube with faces numbered 1 through 6 and a fair coin. What is the probability that the cube will land with a face numbered 4 up and the coin will land heads up? So the first thing to note is it's asking us about probability. Now, probability is written as a fraction. So on top, you have the possible number of outcomes. And again, I'm writing with a mouse, so this is fun. And then the total on the bottom. So if we're looking at the possible for a given data point and then the total possible outcomes. So we always write probability as a fraction. And now it's asking us, we're tossing a numbered cube, so think about dice, and a coin with heads or tails. And it's asking us the probability of getting a 4 on the cube and heads on the coin. So let's write these as fractions. So if we think about a numbered cube numbered 1 through 6, how many 4s would be on that cube? There would be 1 number 4 on that cube. So there's only 1 4 that you could roll. And then out of how many possible outcomes? There are 6 total numbers. So there's a 1 out of 6 chance that I would roll a 4 on that number cube, right? Coin. The coin can either land on heads or tails, so there's 2 possible outcomes there. And if it's heads or tails, there's only 1 heads. So 1 out of 2. Now, when we want to combine probability, we multiply those fractions. Actually, pretty straightforward math here, okay? So 1 times 1, we're multiplying fractions. We just multiply the numerators and we get 1 times 1 is 1. And then we multiply the denominators. 6 times 2 is 12. All right. So correct answer here is A. The probability that that number cube will land on 4 and the coin will land heads up is 1 out of 12. All right. So remember, when you're combining probability, we multiply. We write probability as a fraction. So many chances out of so many total. All right. So that's how you write probability. Let's move on to the next question. I'm glad y'all's screen looks pretty good. Mine's showing all kinds of glitchy stuff. So, but I'm watching on my phone and it looks pretty good on y'all's end. So if you see me squinting, my screen's acting all haywire. So let's look at this one. Number 7, this is geometry, and we're classifying 2D figures. So it says, which of the following best describes the polygon above? Now, really, this question is a knowledge of your vocabulary. What do you know in math vocabulary and what concepts do you understand? There's really no math to do. So let's talk about the vocabulary here. The first word it gives you that you may not know is polygon. Guys, a polygon, I'm going to give you some criteria for a polygon. It's going to be closed. It's going to be a 2-dimensional figure with 3 or more sides. Now, we could say this a lot more technically. If you Google it, it comes up a lot more technically, especially if you look at those mathematical definitions. 3 or more straight sides. let me clarify. And I'm going to abbreviate since I'm writing with my mouse and it's real fun and challenging. All right. So a polygon is a closed figure that's two-dimensional with 3 or more straight sides. That's all a polygon is. And you might be thinking, well, I don't need to know that, Dr. Mulkey, to answer this question. No, you don't, but you might for another question. So I'm going to go ahead and give you that definition. Now, the other word you see here is hexagon. So let's talk about a hexagon. A hexagon, it has a 6 in it that gives you, or an X in it that gives you a clue that it is a 6-sided figure. So let's verify this is a hexagon first. We have 1, 2, 3, 4, 5, 6 sides. All right, so it is a hexagon, which means we can rule out arrow. All right, arrow is not really a mathematical term anyways. So we've got it narrowed down to regular hexagon, convex hexagon, and concave. Now, a regular hexagon is just a polygon with 6 equal sides. So typically when you see a hexagon, now I'm going to attempt to draw this with a mouse, but oh my goodness, it could get real fun. Okay, so pretend these are all equal and straight. So typically when you see a hexagon on a poster or a diagram, it looks something like this. That is a terrible drawing, but you get the idea. I'm going to attempt to switch to my pen and we're just going to see if it'll cooperate. And I'm going to try to draw that again. Nope, it will not. So I'm going to keep working with the mouse. So it is a 6-sided figure. Regular just means it's your standard hexagon, all right, 6 sides. Now, in this case, this doesn't look like what I just described for you or what I attempted to draw for you right here, but that's your typical hexagon. Kind of looks like a stop sign, but with one less side on each side. Okay, now that doesn't look like this, so we can rule out A. Now we're down to convex and concave, and you're either going to know this or not. If you don't know the difference between convex and concave, take your best guess and move on. Don't antagonize over it. Just take your best guess and move on, because sitting here staring at it's not going to make you know those words. So I'm going to give you what these words are, and then you're going to know the answer. So a convex hexagon has no angles pointing inwards. So more precisely, none of the internal angles can be more than 180 degrees. All right, so they will all be under 180 degrees. Now, if you're wanting to know what a 180-degree angle looks like, a 180-degree angle is basically a straight line. So if I put a vertex in the middle there, that straight line, that angle that's created right there, is 180 degrees. So it's basically saying none will be more than 180 degrees. Now, what this typically looks like is just your regular hexagon, but where all the sides aren't the same. So I'm going to attempt to draw another one, and so you can follow me here. So instead of all the sides being the same size, you might see it look like this. Well, that was terrible. I need to go up. Well, yeah. All right, so it's just none of the angles are pointed inward, and this is a really bad drawing. Let me try that one more time. This drawing with the mouse is no fun at all. Okay, so there's one where you can just see this bottom side's a little bit longer than this top side, and these sides are a little bit longer than the ones on the left. So terrible drawing, but hopefully you're keeping pace with me. That would be convex. Now, a concave polygon is defined as a polygon with one or more interior angles greater than 180 degrees. So what it's going to look like is like one of the corners has been pushed in. Concave, it's caved in, if that helps you remember. So if we look at this hexagon that I drew for you a minute ago, if we take this angle right here and push it in, we actually have this figure over here. So you might be thinking, but that's not more than 180 degrees, the interior angle. So we would be looking at this angle right here is more than 180 degrees, because if we extended that as a straight line, if I can. It certainly goes past that straight line. So because this is more than 180 degrees right here, this is a concave hexagon. So even if you can't remember anything about the angles or degrees, remember concave, it's caved in. It's going to look like one of the corners, one of the angles is just pushed in. All right. Now let's move on to the next one. Number 13 is measurement. So we're looking at this one. It says, what is the area in square units of the figure above? Now, area is going to be measuring the inside. Now, we know some basic area formulas, but in this case, this is an irregular figure. So we're going to have to decompose it or deconstruct it to actually find the area. So I'm going to separate this into two basic figures. I'm going to draw a line here to create a rectangle and a triangle. So now I've basically got this rectangle that measures 4 by 10. And then I've got this triangle. Pretend that's straight. And we need to know its measurements because we're going to need to find the area of both of these. So if I look right here, this side of the triangle is the same as this side of the rectangle. Well, this side of the rectangle is 4. This side of the rectangle is going to be 4. And thus this side of the triangle is also going to be 4. The next thing I need to know is its height. All right. So I need to know this measurement right here. So if you're looking, if here to here is 10, but we extend all the way to the end of that triangle is 16. To find this distance right here, we just do 16 minus 10 and we get 6. So the height of that triangle is 6. Now we can do the math to find the area. It's pretty straightforward. The area of that rectangle is going to be length times width, or sometimes you'll see it written as base times height. Either way, base times height, or sometimes you'll just see it BH, or length times width. It's going to be the same thing. So length times width, or the base times the height of that rectangle, we have 10 times 4 is going to give us 40 square units. Now we've got to figure out the area of the triangle, okay? So if you don't know the area of a triangle, I want to show you how to determine that, okay? So if you're like, I don't remember how to find the area of a triangle, I want to show you something really cool. So I'm just going to come down here and I want to draw something. If you take a rectangle or a parallelogram or a quadrilateral, you can look at it a couple of different ways. All those definitions work. And we split it in a diagonal line. What two shapes do we get? We get a triangle up here and we get a triangle down here. So if I find the area of the rectangle by multiplying length times width or base times height, I know I can do the same thing and just split it in half to find the area of one of these triangles. So if you can remember that, it works for squares. If I draw, I'm going to attempt to draw a square. Okay, and I split it with a diagonal line, I get two triangles. So the area of a triangle is going to be, area of a triangle is going to be 1/2 base times height, because it's the same as that rectangle but split in half. Or sometimes you'll see it written as area equals base times height divided by 2. Because if we split something in half, what are we doing? We're dividing it into 2 equal parts. So now we can find the area of that triangle. I'm going to keep working it. I'm going to get area, I'm going to come down here and work, of the triangle equals 4 base times height times 6 divided by 2. 6 times 4 is 24. 24 divided by 2 is going to be 12. So now I know the area of the triangle is 12. The area of the rectangle is 40. So if I want to know the area of this whole figure, I just add those together. 40 plus 12 is going to be B, 52. So really pretty easy if you can remember the formula for area. And remember, if you know length times width on a rectangle, just remember a rectangle is 2 triangles when you split it in half. Okay, so it's 1/2 that rectangular formula. So I hope that helps you remember that. We're going to move on to the next question. Now, this one, the Praxis Study Companion PDF file only had 3 questions for this topic. So I pulled a few from our 240 tutoring materials to present you with a few other practice opportunities for some of those other things in those standards that it didn't hit with these 3 practice questions. So let's look at this one. It's on statistics. It says, what is the median and range of the data set below? So here again, you've got to know some vocabulary. If you know some of your vocabulary, mean is the average. So we add all the numbers up and then divide by the total, or the total number of add-ins. So if we added 7 numbers, we'd divide that sum by 7. The mode is the number that occurs the most frequently, okay? The median is going to be the data point that's in the middle. So if I put them in order from least to greatest, the one that's in the middle is the median. Now, if you have 2 numbers in the middle, you find the average of those 2 numbers. And the range is going to be the difference between the highest and the lowest value. So when I see a data set like this, the first thing I do is go ahead and put them in order. And a strategy I used to do when I was working with students is I would cross them off as I wrote them. So I'm going to put them in order from least to greatest. So I got 18. The next one would be 24. Then I've got 2 26s. You can't just write it once. You've got to write it twice because it's 2 different data points. That 26 occurred twice. Okay, so I'm gonna cross that one off. And the reason I'm crossing them off is to make sure I don't skip one. Okay, so it's just a simple little strategy. And if you're writing with a pencil, it goes much faster than me writing with this mouse. And then 33. And then 35 is going to be our last one. So I've put them in order from least to greatest. And the reason I did this is because it asked me for the median. And the median means the value that falls in the middle when they're put in order. All right. So I'm just going to check these off. So I'm going to just work my way to the middle. 1 on each side. Just kind of crossing them off. And now I can see the number in the middle is 26. So we know our median has to be 26, which means we can rule out A and B. Now we just have to find our range. Now our range is the difference between the highest and the lowest value. So I've already put them in order. That makes it easy. 35 minus 18. Some basic subtraction here. You have a calculator for this test. So if you're like, I don't want to do that math, I want to save a little time, I can do 35 minus 18 and get 17. I can do the math if I want to. Either way is sufficient. So now I can see the correct answer is C. Correct answer, C. So pretty straightforward as long as you know what mean, median, mode, and range mean. So definitely review those and know how to find them. All right, our last question for today. It says, which type of graph would be best for showing changes over time? So we're looking at representing statistical data, and how we can do that is with charts and graphs. Now, a common mistake I've seen among many candidates preparing for these exams is when they don't know the answer, they pick the choice that sounds the most sophisticated. I don't know what a histogram is, so I'm going to pick that. That sounds good. That sounds great, without even thinking about really what the question's asking. And so a lot of times they'll put that sophisticated word first, so it's even more tempting for you to just pick the one I don't know. If I don't know this answer, well, I'm gonna pick the word I don't know, so maybe that fits. But let's talk about this. Which type of graph would be best for showing changes over time? So let's pretend you don't know what a histogram is, and let's go ahead and talk about these. A line graph, y'all know what this looks like. So you'll have a point, and you'll have a point, and you'll have a point, and maybe another point, and they're usually connected with, you guessed it, a line. So we're looking at plotting some change, all right? Gives you a hint. A pie graph or pie chart is going to be a circle broken up into parts, and it usually shows us some percentages within there, okay? And then a bar, you should all be familiar with what a bar graph looks like. It'll be a bar, and this will be for one data point, and then we'll have another data point, and it'll be another bar, and so on and so on. So if we look at these, a bar graph is best for showing comparison. Now I'm going to abbreviate because I'm not going to write all that out with a mouse, but comparison. A pie chart is looking at portions or percentages of a whole. So we're looking at a whole group of something, and we want to break that into portions or percentages. And then a line is best for showing change, and it's really great for showing change over time. All right, so the correct answer here is B. Now I'm going to tell you what a histogram is. A histogram actually looks a lot like a bar graph, but it's not quite. Each bar, instead of standing for one data point, will stand for a range. So it's showing you that bar goes from 50 to 60, and how many data points landed in that range of 50 to 60. So it might go up to 100 to tell you 100 data points were in that 50 to 60 range. So a histogram shows range. So if you're not familiar with the different types of graphs, that's another great thing to brush up on. All right. Now we're just about out of time, so I want to remind you, remember to know your test format. And we got some great questions last week about how do I know how many questions I need to get right. Go to the Praxis website, and you're going to have to look this up by state. It's determined by each state or agency. So I can't tell you that exact number in this video because I don't know what state you're in. So go look that up. It's not difficult. Just go navigate the Praxis website. If you can't find that, drop me a comment and I'll give you the link so that you can find it. You need to know what you need to get. Familiarize yourself with the screen. What does it look like? You can go and do some practice at this website right here. You're going to just Google Praxis and you'll get there, or Google Praxis preparation. That'll certainly get you there. There's also an on-screen calculator that you can practice with. I highly recommend you do that because the on-screen calculators can be a little bit clunky. And if you're not used to that, it can really slow you down. And then I'm going to recommend that you always practice your pacing. Not just can I do the math, but can I do the math fast enough? Can I move through these problems quickly? Now, again, here's what the calculator looks like. And you can see right here where you can request access to that calculator to practice. So I highly recommend you do that. I'm so glad you joined us today. I'm sorry about the internet difficulties and my pen not working. Of course, technology doesn't work as soon as you're live and trying to help people. So I appreciate your patience with me today, and I'll have that fixed the next time I see you. Again, I'm here every Tuesday, and so you can catch live videos at 1 Central Standard Time to help you prepare for your exam. We finished up the elementary math, and we're going to move on to another subject next week, so I hope you'll tune in. If you have any questions, if you're watching this later, not live, or you're watching this on YouTube, drop a comment in if you have a question, and I will take a look at those. Every Wednesday, I do office hours in our Facebook group where I try to answer those comments. If you're watching this on YouTube, come join our Facebook group so you can drop some comments in and I can help you there. If you have any questions, I'd be happy to help. Our videos stay live on our Facebook page, or stay active on our Facebook page. You can just scroll through the feed or click on the videos tab over to the side. We also put them on YouTube. You can go look at our Praxis playlist. If you want more study materials, you can check out our study guides, and for free materials, you can look at our resources page. I don't see any comments right now, so I'm going to close out this video before my internet decides to actually crash. So thank you so much for tuning in with me today, and I hope to see you next week. Again, I'm Dr. Kristy Mulkey with 240 Tutoring. Thank you.